Happy Thursday, everybody. We're up so early that the street lights are still on. We're at NASA, and we're here to check out the Magnetospheric. And look who it is. We have to keep Tim around. Every time I can't stumble on words, you know, Tim's got to be here to correct me. Magnetospheric Multiscale mission. So we're launching a rocket today, and it's got like 4 sub-satellite rockets. It's going to be super cool. Well, right now we got to stand out here and wait because I misjudged time and we got to wait 45 minutes to get our press badges on. Check out this sunrise. It does look like the shot is blurry, but I can assure you it's not blurry. It's just so foggy outside. That's awesome. Hey, we're on NASA property. We're coming up on the vehicle assembly building up in the distance. And this is where we're heading, like it says. NASA Social. So this is the countdown clock for our mission today, although the time is not accurate right now. The NASA Social building is located over here. So you have the vehicle assembly building over here, which is extremely tall. I wish in perspective you could see. Hopefully later we'll be able to get a little bit closer. You can see just how tall it is so that they can get rockets in and out of the building as well as the space shuttles. Over here you have the return basin. It looks incredibly awesome in the morning with all the fog burning off. Hey, we're inside the media building and they gave us a grab bag for our event today. We got this really awesome patch. We got a sticker. This is going to go on my new laptop. And we got a little model, paper model of the MMS. That's pretty cool. Got a little fun facts and stats on it too. Got booklets, the mission overview. We're going to go to the news annex, get a little briefing for the mission today. Hey, we've wrapped up our little press introductions, our social media introductions. Now we've got our group here. We're going to get on that bus that says Kennedy Space Center. Pay no attention to that countdown clock that still says 22, 22, 22, 22. That doesn't mean anything, they're just doing a test on that right now. But this is our entire group. So, there's roughly like 50 or so people here with us. We're on our bus. We're on
Todd LeVogue. Controlled facility. As a result of that, we're going to have to ask everyone to leave cell phones and cameras on the bus here. We're not going to be able to take them inside that building. It is the control center for the launch, so we are going to go and see that. But the restrictions there are due to ITAR, which is the International Trafficking of Arms Regulations, which is one of the laws that NASA has to, NASA and the Air Force and everybody else has to go by. So I do apologize for that, but I think it's going to be worth seeing, going inside and everything. And when you come out, you can give everyone your impressions of it.
So we just took a tour of the Atlas Control Center. Really awesome stuff. We got to see where mission control is for launch today and took a look all around. Couldn't show you guys confidential stuff. Just truly amazing. It's an awesome day so far.
The officer in I Dream of Jeannie. If you ever watched that show on either when it was at first out or on reruns on things like Nick at Night and so on, TV Land. So this was used as the exterior to that. The center director's office is on the 4th floor, the tall tower that's in the middle of the building. So that's where the main headquarters area is here. 41, which has the rocket outline. We'll be visiting there a little bit.
Like this one on time too, right? Is it racing rods? Yeah. You may not be on here, but
So the spacecraft, the launch vehicle, all the components load in from the north side of this building. As we pass it, you can look back at it. Probably the door is closed today. And they are. And you'll be able to see that when we park and get out too. So the launch vehicle and spacecraft are mated together, and that building that we just passed.
So we actually are out by the rocket launch building right behind me. I think that is the coolest thing in the world until they turn around and you see this in front of you. That is the rocket. This is amazing. For something that could not be any cooler in the world, I'm standing right here, probably a good 500 to 1,000 yards away from the rocket. This is amazing. This is the actual MMS rocket, Atlas V, that will be launching tonight for our mission.
Struggling? You know, to have the Atlas on my shoulders. No, that is great.
How far away are we?
What? Picture with him?
Alarm Complex 41 is scheduled for today. We'll use the keyboard warning system to advise you of required actions. Launch toxic shelters may be required for your protection. Approved launch toxic shelters are identified with the brown sign at the main facility entrance. Your cooperation is essential to avoid personal risk or injury.
Hey guys, this is Scott here. So this is it. This is the Magnetospheric rocket. This is what I drove like 1,000 miles. Really excited to show you guys the launch.
Okay.
This is what the group looks like.
Oh my gosh.
Man, we're wrapping up here. I totally don't even want to leave. But tonight we are only going to be 2.1 miles away from this launch. You cannot get closer to this launch tonight if you are not part of this NASA social meetup, unless you're part of the ground crew and they're only 2 miles away. So we're going to be extraordinarily close, hoping beyond hope that this goes up. This is amazing. So you've got these cameras here that watch the launch, monitor the launch, and then about 2 hours after the launch they come and collect these cameras and then make sure that nothing went wrong. So it looks pretty awesome.
Oxygen in them, and the other propellants that are going to be used for the different stages of the rocket and everything here. You'll also see the flame trench as you come by here on the left. That's where all of the smoke and fire will shoot out from the pad. The berm here, the big grassy hill, will disperse that and put it up away from the equipment around here. So tonight, this is not an area you necessarily want to be in. We'll be at a nice safe distance, about 2 miles away. So that should be a pretty good view of everything.
So we're going to the cafeteria, which by the way has a payloads experiments truck outside. I don't know if the two things are connected, but we'll find out soon. So we stopped and had lunch at Subway on site, and this is across the street. I don't think you can get out a cooler job than that. Have that in the background while you're eating lunch during the day.
I'm really curious about to use for one of the equipment, the landing support equipment for the shuttle.
Near the top.
What's going on in there? Columbia's remains are upstairs in the A tower. We can't go up there and take you guys up there. I wish I could. It's up on the 16th floor, but there's a lot of history that went on in that place. I worked in this building for about 10 years. My first 10 years I worked out here. So I know it pretty well. I know all the sleeping places is at night. I mean the places we take a rest.
Hey, we're going to get into the vehicle assembly building now. And to give you an idea, this is how big the building is. This is how big I am. The American flag that's on the building, I believe, is the size of a football field. So that should give you just how large this building is. So what I want to show you guys here is that on the girders here, they have markers that indicate just how tall some of these ships are. So I'm going to zoom in here. That is the Shuttle Marker. We've got, losing it, got SLS, and you got the Saturn V. And we were just told that the SLS final configuration will actually be taller than the Saturn V. It's just absolutely amazing just how tall these rockets are.
So there were modifications done to the building to take it from working on a Saturn V rocket going to the moon to working on a space shuttle rocket to fly to low Earth orbit, to build the space station and do all the things we did with 30 years of the space shuttle. We currently are modifying the building and upgrading the building to support the Space Launch System, which will be the future for the government spaceflight. So, that kind of being said, you look at this pictures. And the first thing I'll point out is this is a really interesting collection of photos. August of 1963, you can see it's just sand. Some of the pilings are being put in place. 4,200 something pilings, 16-inch in diameter, 150 feet to bedrock. As the building was being built, you know, it progresses to where here the building is essentially complete. July of 65. That's right at 2 years. Okay, which would be amazing to do nowadays. So that brought up the building to preparing for Apollo. This is as we evolve. History, right here, the American flag, that was painted on there in 1976. The bicentennial of the United States. That's what that funky star was, the bicentennial logo. So that was painted on there. So you can look at pictures of the VAB, and if it did not have the flag on there, it was before 1976. We have an Apollo Saturn V rocket in one of the high bays in this photograph. We have a space shuttle stacked in one of the high bays in this photo. Then there's some graphical renderings of what the Space Launch System rocket will be. Now, the platforms that you see here that have the gray and they have the yellow arcs in them, those platforms extend and retract to give access to the different levels of an Apollo rocket.
Those are the platforms right there.
Those platforms were actually removed from the building, taken down on the ground, modified, cut, changed the shape, so they were utilized for the space shuttle. So those platforms really were reused. As we go to SLS, we have taken those platforms, removed them completely in High Bay 3. I don't know where they are, they're metal recycled now. But we are putting new platforms in which are depicted within this graphic. The idea is the new platforms are going to be a lot more functional and modular. The platform is basically a yoke with a dance floor put in there. It's actually called an insert. That insert is just a piece of metal, and if we change the shape of the rocket or built a different rocket, you would only have to change the dance floor or the insert and not the structure. As we are transitioning, we removed 750,000 feet of wire. And we took these cable trays that look like ladders, you may see them. We took those and emptied them and repopulated them with like 3 fiber optic cables like this. You can network so much things now that we take for granted that even in the shuttle program there was not the capability to do that whole lot of networking. So this is a very interesting dynamic change. Historically, if you look over in that direction, those orange platforms that are raised up, those are actual Apollo platforms that were left over from the Apollo days. So those are abandoned, we're not going to take them down, there's no real use for them at this point. So those are Apollo era platforms. Okay. Then as we look to our left, you see this big yellow piece. This is actually an overhead crane. I'm going to try to see a picture of it, and I don't have it. Well, here you go. This picture of the Space Shuttle Orbiter in the transfile, this crane is what you see right here. This is up here, and it usually rides on 2 rails. Look up, there's a yellow rail. I see one over there beside the 2 red pipes. There's a yellow rail there, and one over overhead. So this crane, if you imagine, is lifted up, rotated 90 degrees, and placed on those rails, it will be able to move from one end of the building to another. It's got a 175-ton capacity. I can almost lift that. And the high bay to the left. I say that because it's only 210 feet tall versus 525 feet tall.
210 feet on this side. 520 feet on this side.
I don't know where that, but it's been surpassed by other buildings. But it still is the largest single-story building in the world. As you can see from the ground, 525 feet up. That makes it the largest single-story building.
So in case you didn't hear what he was saying, this is the largest single-story building in the world. This goes from their size of 1 floor, like from here, from floor to ceiling. This is 1 floor, consider 1 floor. 520 feet or so, largest building. This crane will help maneuver some of the crafts into place. It rotates 90 degrees, moves along. This is in the middle of being refurbished.
Right, but this allows the platform to remain level regardless of the little bit of change in going out to the launch pad or going up the launch pad. So the crawler actually transports itself underneath the mobile launch platform, which I think you're going to see one of those out here. Anyway, it goes up under that, lifts it up with the rocket on it, transport it out to the launch pad, and then it gets out of the way for launch. We have two of them, and this is crawler transporter number 2. It's being upgraded in its capacity. Like I said,
so this is one of the transports to bring rockets or spacecraft from the vehicle assembly building out to launch pads. You can see how launch it is. So the rocket gets lifted up onto the mover and then out to the pad.
So it goes really fast. It goes about 1.5 miles an hour, but with a space shuttle on there, we limited the speed to 0.8 miles an hour. One reason is when you have a rocket that's very tall, you start this thing going, and you get that vibration, and you put a lot of load on the attach points. So typically, with a spaceship on there, it was 0.8, and 0.8 is about like this. There's a mobile launch platform right there. There's like the ceiling, that's really the bottom of the mobile launch platform. And the top of it is just above that catwalk. Okay, so it's, like 25 feet thick. So, on top of that is a space shuttle stack.
But is it inside here?
Yep, it's right where that is. Right where that is. It's out there. It's still in the building, but it's out there. The doors open up, and the crawler takes it out that way.
Is it a door like that one?
Yeah, well, it's exactly. This is the same thing. The 2 horizontal doors are now on this one open. Yeah. Okay, and then the vertical door. Okay. See that? The 7 vertical doors are all on the rail.
So that's on that side.
Right, it's the same thing.
So over there, it would be like right in here.
Yeah.
Right in here where the crawler right here.
Right. The crawler would be here, and above the crawler would be the mobile launch platform, and then up on top is the rocket.
So this is the mobile launch pad on this side. It straight up looks like a board ship underneath, but it is pretty amazing. There is another crane up top, so just giving you the view of where the crane is when we described it earlier. And come all the way down here. So, for the missions that were called out on the wall back there, we just asked. And the answer is why they chose them is because they filmed Transformers 3 here. And Michael Bay, when he was filming the movie, chose those particular missions to put on the wall. No rhyme or reason, and there's really not a lot of guessing as to why they would choose those particular missions, but they were, and they kept them on the wall since the filming of the movie. So by the way, right across from the vehicle assembly building, you have all of the news outlets had buildings here as well to watch the launches that took place over there. But you have CBS, Reuters, the Sentinel, and you've got the general NASA News Center over here we're going back into. This is where we're heading now, into the news facility, television studio auditorium. All right. Yeah, this is very cool. So,
You gotta be back here at 9:30.
I'm going to do a live broadcast with
You gotta be back at 9.
the web. So as folks are getting settled in here, you can see there's a camera there, we have a giant video screen there, and then behind us, we have 2 cameras back there, and a production studio. So they may be looking for us to answer questions, or ask questions rather, and this is what it's going to look like.
To this MMS NASA Social. We're coming to you from NASA's Kennedy Space Flight Center. I'm Aries Keck from Goddard Space Flight Center in Greenbelt, Maryland. And we've been down here with about 50 media and social media people doing tours of Kennedy, learning all about the MMS mission. We built the MMS spacecraft up at Goddard. They are 4 identical spacecraft, and we're going to be telling you about them for this entire period. And launch, I'm hearing, is still on schedule. It's 10:44 p.m. East Coast time tonight. 10:44 p.m. East Coast time tonight. And if you want to find out and follow about the mission and find out all kinds of information as we go up to launch, and even after launch when we get the first science results from MMS in about a few days, go to #MagRecon. Again, that's #MagRecon. If you go there now, you'll see what everybody in the room has been tweeting all day as we've been walking out through the Kennedy facilities.
I'm Karen Fox with the Heliophysics team at NASA Goddard. And we've got 2 hours to go through all sorts of wonderful details about this mission. But I want to lay the groundwork here with just a very small vocabulary lesson. Okay, so we're doing a nice few basics. I'm going to define 4 things: MMS, heliophysics, plasma, and magnetic reconnection. So for starters, MMS. What does MMS stand for? It stands for the Magnetospheric Multiscale mission. So, magnetospheric, the magnetosphere is a giant bubble of magnetic fields around Earth. Multiscale just means lots of different scales, big scales, small scales. And MMS will be studying the magnetosphere at a wide variety of scales, and will be going down to smaller scales than have ever been done before, and at speeds faster than have ever been done before. Number 2, heliophysics. Helio, sun, physics. So, you know we've got something to do with the sun here. We've got solar physics is absolutely part of heliophysics, but the sun actually has influence over a much larger region. The sun is constantly spewing out something called the solar wind. All these solar particles, they go out way past the planets. And there they encounter the rest of the stuff, the rest of the universe. And there's a boundary there. That entire gigantic bubble around the sun is called the heliosphere, and heliophysics studies the way the sun interacts with space all the way out to that very edge, and of course, how it interacts with near-Earth space. So the sun-Earth connection is a key part of heliophysics. Number 3, plasma. Plasma is a good one. Plasma is what dominates the rest of the universe. It is something we don't experience regularly on Earth, but it is truly what fills the universe. It is what is in space. It is what makes stars. And what's most important for us right now, we're going to be talking about it in detail very soon, but what's most important for starters is that it travels with magnetic fields. So there are magnetic phenomena going on inside plasma all the time. That if we're going to understand the universe, if we're going to understand near-Earth space, we need to understand. 4th and final, magnetic reconnection. So, MMS is really going to be focusing on this particular magnetic phenomenon. What happens is, when magnetic field lines, you know, they point from south to north. We've seen batteries, or a lot of ways in which you see that on Earth. You've got a field line pointing this way, and a field line pointing the opposite way. When they come together, everything realigns. Sometimes there are huge explosions. Always, there is a release of energy. Particles go zooming off into all direction. And this phenomenon powers stuff all over the universe, which we will be discussing in great detail today. So that's the basic. Opposite field lines come together. They get too close, and they have to completely realign. That is magnetic reconnection. So we have a demo from Glenn Collinson, who is a heliophysics scientist at NASA Goddard.
Hello everybody. Like your cap, Empire Man, good to see you. Hi. So I think John described it best earlier to me, that I feel currently it's equal parts euphoria and terror. That like 5 years of work is about to, for me personally, is about to be loaded on top of a giant machine, and there's going to be a huge explosion underneath, and this roar of dragons fire, and the earth shakes, and it's going to be terrifying and very exciting. So I'm really here to try and demonstrate a little bit these 2 buzzwords that you're going to be hearing a lot. One is plasma, what is that? And the other is magnetic reconnection. So first of all, to do to plasmas, I think since I'm British, as you might be able to tell from my accent, I'm going to make you a cup of tea. So what do we need for some? Well, we need a cup. We're going to need some tea. I personally prefer Assam. And then, of course, the next thing we're going to need is some water. And I have some water right here. And so here is some water. Obviously, less useful for making tea. So that, this is solid water, right? You're very familiar with this. But if we apply some heat, we will melt it, and we will get it up to around 0 centigrade. Sorry, 32 Fahrenheit. We will produce this liquidy stuff, which I can use a drop of right now. But if I could address you, America, directly at this moment. America, I love you. You make wonderful things. You make the MMS spacecraft some of the most incredible machines ever built by man. But you can't make a cup of tea. It's really not that hard. I mean, unfortunately, many of us believe that you make tea by pouring boiled water over tea. That is not true. You make tea by pouring boiling water over tea. Boiling. And I just got some here. So 100 degrees centigrade. Some people feel that in Fahrenheit. I'm sorry, I think in
212.
Thank you. So here I have. I just boiled this up, and you can see. Can you see the steam coming off of it? That's a good sign that you're going to make a good cup of tea. So as the steam comes off, I want you to realize, of course, we've now entered our third state of matter. We have a gas. So here we have our solid, we have our liquid, and here we have a gas. And here we have some milk. But there is another place that we can take this to. What if I was to take the steam and gather it together and then heat the steam? And I keep heating and heating and heating until thousands and thousands of degrees. There's a fourth place I can take this to. There's a fourth state of matter, and that is a plasma. So, got to do this properly. So plasma is essentially, what we would do is we would take the steam and we would put so much energy in, we would tear the hydrogen and oxygen apart, and then we would apply even more energy, and we would take the electrons from the hydrogen and that oxygen, and we would tear the electrons off. And now we will have a soup of ions and some electrons. And so the ions, the bits are in the middle, and the electrons go on. And this is a plasma. And the reason why I can't make you a nice little cup of plasma tea right now is, as you can understand, it's incredibly rare on the Earth. To get that kind of temperature is extraordinarily difficult. So really, the only places that you'd see it is in, say, a bolt of lightning or a rocket exhaust. So tonight, be watching the plume. We have a machine that will make some plasma for us, and it's called the Atlas V rocket. And that's really what a plasma is. So obviously, if we want to study plasmas, because they're so rare on the Earth, we need to go to where they're common, which is space. So what I have here is a little magnet. And if I pop the magnet inside, you can see that like a pattern starts to form on the inside. Here, I'll get a bigger magnet. This is NASA. We have ridiculous magnets here. This is a very powerful magnet. Can you see there's like a loop forming here? So this is the north pole of the magnet, and this is the south pole. And what the iron filings are doing in here is they're kind of joining up, click, 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 like little daisy chains. And they're sort of making a line. They're tracing out a magnetic field. So you can actually sort of see the field. And in fact, in physics, we will talk about magnetic field lines. I don't know if you've heard that title, but that's what that means. Now, you should know that there aren't actual physical lines out in space anymore. It's all a continuous thing, because gravity is a continuous thing. But it's a way of thinking about it. So what if I don't just have, what if I have two magnets? Right, so I have one magnet here, north and south pole, and then I bring in another magnet. And can you see that there's now two loops forming? And in the middle between the two, you can have a thing called reconnection, right? Where the magnetic field lines from this one, they're not just making a loop like this anymore. They're actually joining up with the magnet from the other one. And that's really all reconnection is. But I can't really describe to you how it works, because we don't know. And here's the big secret. You're going to meet lots of people who are all very knowledgeable about the field. You're going to meet some of the best experts in your field. I'm not one of them. You're going to meet some fabulous, knowledgeable people. But the thing to understand is, none of us understand this stuff. We don't understand a lot about how space works and how the sun works. And this reconnection is really the big bugaboo about this MMS mission. And with that, I think I sort of describe it.
Together, and that there is a way for to be able to track things going around the heliosphere. What does that mean in practice, and how are people actually collaborating? How can they work together?
Great question. Well, first thing is the data is public data. We don't keep the data for ourselves. We don't keep it just the MMS team. As soon as the data gets to the ground, it's validated, make sure it's good data. It gets dispersed worldwide. It gets dispersed to our other heliophysics partners. All the other spacecraft that are working together. So as you said, you want to understand that system. As that solar storm comes towards you, you want to know about it. So data from our other spacecraft are being fed to the MMS team. We coordinate. The MMS data coordinates a lot with one of our other spacecraft called Themis, another mission, which actually has 5 spacecraft, that will look at a global nature. So again, by having the data publicly available and sharing among all the other scientists that are operating our larger heliophysics system observatory, we can work together.
The universe is full of plasma, right? And the universe is also full of magnetic fields, and plasma moves around and it carries the magnetic field around with it. And a great example of this is the sun. So the sun's outer atmosphere, the corona, is actually a 1 million degree plasma. And because it's so hot, it actually expands out into interplanetary space at supersonic speeds, all the way out to Earth. So when it hits the Earth's magnetic field, you can think of Earth again, like Lynn was saying, is it's just this giant bar magnet that's rotating around space. So it has its own magnetic field. And the sun's plasma smacks into the Earth's magnetic field in the Earth's plasma, but they don't really want to mix. It's sort of like pressing 2 big balloons together. Something's going to give. And so what gives is that some fraction of that magnetic energy is converted very rapidly into plasma energy. And you get this enormous energy release and all the consequences, space weather consequences you heard Jeff talk about. So the reason this is great for MMS is because it provides us really an ideal laboratory for studying this process. Because at the dayside boundary, where the solar wind meets Earth's magnetic field, reconnection is happening there pretty much constantly.
So now let's zoom in on the spacecraft themselves. So you've got 4 of them, okay? And you're going to be looking at these 3-dimensional structures, but so why exactly do you need 4, and how are they going to be moving through the magnetosphere to give the kind of measurements that you need?
As they go around the closest approach to Earth, it kind of gets stretched out. But the apogee of the orbit is cutting right across this magnetopause boundary. And as it reaches the apogee, it's in a sort of perfect tetrahedral formation. And the reason we like this is that, as Glenn was mentioning, the actual reconnection site is a very complicated multi-scale structure, and it's 3-dimensional. And if we only had 3 spacecraft, well, then we have a triangle, and that's basically giving you a plane. You might be able to project things into that plane and get some information, but you're losing a lot of information. So to get that 3rd dimension, we need to have at least 4 spacecraft. So that's why we have the tetrahedral formation.
The tan section at the bottom is the tanks for the Atlas booster, comprised of 26,500 gallons of RP1 and about 60,000 gallons of liquid oxygen. And with the RD-180 engine at the bottom, a single engine with 2 chambers. Up on top, through some interstage adapters, mated to that will be the upper stage Centaur, liquid hydrogen, liquid oxygen, and a payload adapter and the MMS payload. So you see in the first picture on the upper left-hand side, that's the booster going up inside the bit. We rotate it up vertical and set it up on top of the launch heads. That happens in 1 day, and then the next 2 days we put 2 solids on. And that's that picture in the middle, up on the top. And after that, soon after that, we put the Centaur upper stage up on top, and inside you see it inside the bit. And then at the same time that that's being assembled, you can see the picture of the MMS spacecraft over at the Payload Processing Facility at Astrotech. That's being processed and assembled and checked out at the same time we're assembling and testing the launch vehicle. So when the launch vehicle is ready for the spacecraft is ready for the launch vehicle at the same time. We mount the spacecraft, all encapsulated, the encapsulated assembly, to the top of the launch vehicle, and we roll it out like we did yesterday, ready for tonight's launch in the right-hand corner. Is in the box here, and we're taking the lid off, and we're at, should be at Astrotech here. Just delivery of the spacecraft and receiving inspection. This here is, that last picture was the booster, Atlas booster being loaded onto the Mariner in Decatur, Alabama, and then offloaded here at Cape Canaveral. So it's rolling out, it's already here on this, and that's the booster, and the Centaur being loaded into the Atlas Spaceflight Operations Center. At the same time we're doing that, we're processing the spacecraft at Astrotech, getting ready for the day, for tonight. The booster's already erected, and some of the pictures I showed before, the Centaur is getting ready to go up there. I can see that. And the Centaur is up and about to be mated. So here's some of the solid rocket motors that are going on top. This is the one that's on the north side. There's the Centaur being mated to the top of the launch vehicle. This That's the spacecraft over at Astrotech, and they're doing some final inspections and mating it to the payload adapter. The spacecraft doing their final closeouts. And this is the encapsulation process. We're putting the payload ring around the 4 MMS payloads. And we roll out early in the morning, so as not to upset traffic, and be at VIF at 5:30. The most thing you'll hear a rumble. It won't be right away. It'll be 30 seconds or 40 seconds into flight by the time you hear the rumble. But you'll see the light right away, especially with a nighttime launch. So that's the biggest thing. The biggest sense you'll get is the light. If you're standing, if there's water, which is a lot in Florida, between you and the launch pad, that'll all light up. The fish will jump out of the water. I've seen it every time, and you'll get that light sense as it goes up, and you'll be thrilled at the whole thing. So it's your first launch, and so I have 160 under my belt, and it still happens.
Awesome. The program that I work for is doing is we're actually revamping the entire Space Center here to get ready for this next most powerful rocket we've ever built that we're going to go launch. And it's actually just a really exciting time. I'm sure as you guys were driving in, you guys noticed some of the big things that were going on, right? So as you drove into the press site, if you look to just past the VAB, the Vehicle Assembly Building, you see this big 355-foot tall mobile launcher structure, right? That's pretty cool. And so what you see is we're actually getting ready. We're building hardware. This is stuff that's getting very close to being finished, to going into the testing phase, to go launch this next generation of heavy lift vehicles, to really launch our astronauts to that next point, much further into space than we've ever gone before. We want to kind of build into an eventual flight rate that'll allow us to go to Mars, but we want to be able to do it in a stepwise manner that's intelligent and efficient, and gets us there in a timely manner that we can test, build, and kind of work our way up to it. So that's what we've been working on.
So when we talk about the next level of manned missions, and of course, I'm wearing Buzz's shirt, realistically.
Solar Sciences background driving here. One last question that came in to ask NASA, and I'm just going to quickly get past
So unfortunately, as I asked the question, my camera's memory card filled up. So guys, I asked the question, because I'm wearing the Buzz shirt, about when is our next manned mission to Mars. You saw that little footage there. But unfortunately, my memory card on my main camera completely ran out of time when Tim was filming. So we have to check and see if they are going to put up this video on YouTube or not. But basically, the answer that we got was that the next manned mission to Mars, or when they're planning, not the next, but the manned missions to Mars that they're tracking to at this point is sometime between 2020, more realistically 2030. But they are looking to do that with the next wave of manned missions and looking for a mix of private funding and government funding, but definitely looking to make the most efficient use out of the money that they get, but they are looking to get out that way. So we made a trip back out here to the clock, because now the clock is actually precisely 4 hours, 28 minutes, 40 seconds. And Fox 35 is doing their remote right now, talking about the clock and their countdown. So now we can film Fox, filming Fox. So you can see right there, we've got our Atlas rocket on the launch pad. We've got a little under 2 hours to go. So the countdown is on. This place is buzzing right now. So there's a lot more people. Regular press here now as well. So the rocket's on the launch pad. We got about 6 minutes to go before launch. Everything is a go right now. This is amazing.
You'll be able to see the shockwaves from the water.
This night launch is so much bigger than the sunset.
See if I can get stage stuff. That'd be kind of cool. I don't know when in relation to now it'll happen, but we'll see.
You can clearly see it up there still.
Quite a way to go.
Oh man, you're still streaking again, aren't you? The SRB should be coming off the screen of those. Solid should be about to fall off. And with the weather it is, we should see them tumble for a bit too.
Oh my God, you cried!
Oh, is that it? I don't know. I can't say for that. There's too many sirens in my way.
Something changed.
There it is, there it is.
Wow, that's, yeah.
But we should reignition next, Centaur.
That was one of the coolest things I've ever done in my life. Back on the bus, time to get home. Hey, we're back home, and it was an unbelievably awesome day. Everything from going to the vehicle assembly building to going to the launch control and then to see the launch and not have something scrubbed and have it a beautiful weather and watching everything go off as intended. I couldn't ask for a better day. Today was one of the best days that I think I've ever had. So I want to make sure I thank all the folks at NASA and social media team for having us out there. Jason, Chris, Aries, Brittany, and Karen, and everybody else, if I'm leaving anybody else out of the loop there. Unbelievably awesome day. Thank you so much. I don't think that any videos that we put up could do justice to the awesomeness that was today. So if you guys are not following the folks at NASA and NASA Social now, I'm going to put the links down below for all of the accounts that I think that you guys should be following, and the accounts that are tied to the specific mission that we went to today. And if you look at hashtag MMS or hashtag MagRecon, you can also find out how this particular mission is proceeding, you know, beyond today. So it was just absolutely awesome. But on that note, I'm going to get some sleep because I need to be back up in another 5 hours or so, or 4 hours. So thank you for all the likes. Thanks for the comments. Thanks for the subscriptions. If you're new to the channel and you like what you see, click subscribe. And on that note, treat others the way you want to be treated. See you guys tomorrow. Thanks. Bye.